Hello, welcome to The Extraordinaire, where we are committed to the relentless pursuit of excellence. If you love tech, you love to learn new things, or you just want to skill up, subscribe to the channel so that you don't miss any of our content. Today, we are going to continue from where we left off, talking about exceptions and errors. If an unhandled exception occurs inside an except session, it will have the exception being handled attached to it and included in the error message. Let's see an example of that. Create an example file here, call it example9.py. I will try open database.sqlite except OS error, raise runtime error, unable to handle error. If we run this, first of all, let's close this. Let's cd into exceptions and errors, or errors and exceptions. Yeah. We'll say Python 3 example 9, and we get our error message here. So as we can see, we have the initial error for opening the database here, and then we have the other error that is being changed to it underneath, unable to handle error. To indicate that an exception is a direct consequence of another, the raise statement allows an optional from clause. So let's see an example. So let's say we have, comment this out, we have a function called funct. In here, we raise a connection error. Then we try to execute that function, except connection error as exe. We'll say raise runtime error, failed to open database from exe. Save that, clear, run this example. We get failed to open database. You see here that it says the above exception was the direct cause of the following exception. So this first one caused the next one. It also allows disabling automatic exception chaining using the from none idiom. So if we don't want to see this exception chaining, we can say try open database SQLite except OS error, raise runtime error from none. This time around, we are not going to see any exception chaining. So we only get the error that we got, that we raised in the except statement. For more information about chaining mechanics, see the built-in exceptions. I'm going to add a link to the built-in exceptions in the description. Programs may name their own exceptions by creating a new exception class. We are going to take a look at classes in a later episode. Exceptions should typically be derived from the exception class, either directly or indirectly. Exception classes can be defined which do anything any other class can do, but are usually kept simple, often only offering a number of attributes that allow information about the error to be extracted by handlers for the exception. Most exceptions are defined with names that end in error, similar to the naming of standard exceptions. Many standard models define their own exceptions to report errors that may occur in the functions they define. The try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. For example, let's create a new file here. So save this as example 10.py, and here we're going to say try raise keyboard interrupt. Finally, print goodbye world. All right, now let's run this. Example 10. If a finally clause is present, the finally clause will execute as the last task before the try statement completes. The finally clause runs whether or not the try statement produces an exception. If an exception occurs during the execution of the try clause, the exception may be handled by an except clause. If the exception is not handled by an except clause, the exception is re-raised after the finally clause has been executed. An exception could occur during execution of an except or else clause. Again, the exception is re-raised after the finally clause has been executed. If the finally clause executes a break, continue, or return statement, exceptions are not re-raised. If the try statement reaches a break, continue, or return statement, the finally clause will execute just prior to the break, continue, or return statement's execution. If a finally clause includes a return statement, the returned value will be the one from the finally clause's return statement, not the value from the try clause's return statement. So let's see some example of that. Comment this. Write another example here. Define a function bool underscore return try return true, and finally return false. So run this. Okay, we didn't call it. So print bool return. What do we get? We get false. Reason being that the return statement will return the value of from the finally return section, not that from the try. Okay, let's see a more complicated example. So we define a function here, call it divide x comma y. We say try results equal x divided by y. Let's give some space. And then we say except 0 division error, print division by 0, else print result is results, and finally print executing finally clause. Now let's run it. We're going to do, let's say, okay, just call them, because they already have print statements here, so we don't need to print again. So divide 2 by 1. Let's go in and run this. Example 10. The result is 2.0, and we get the finally section being executed as well. Let's see another example. Divide 2 by 0. Run this, we get division by 0. So here there was an exception and it was handled by this except clause, so it prints this message. What if we do divide 2, 1? What do we get? We get an error message. Why? Because 2 and 1 here are strings, and they are not allowed to perform arithmetic operations on strings. So that's why we get this error message, say unsupported operand types for division operation, string and string. As you can see, the finally clause is executed in any event. The type error is raised by dividing 2 strings. It is not handled by any handler here, so it is raised after the finally clause has been executed. In real-world applications, the finally clause is useful for releasing external resources such as files or network connections, regardless of whether the use of the resource was successful. Some objects define standard cleanup actions to be undertaken when the object is no longer needed, regardless of whether or not the operation using the object succeeded or failed. Let's look at the following example, which tries to open a file and print its content to the screen. So if you see this, if you take a look at this example here, this code here, the problem with this code is that it leaves the file open for an indeterminate amount of time after the part of the code has finished executing. This is not an issue in simple scripts, but can become a problem for longer applications. The with statement allows objects like files to be used in a way that ensures they are always cleaned up promptly and correctly. That's why we are recommended that we always use this syntax for opening files. After the statement is executed, the file F is always closed, even if a problem was encountered while processing the lines. Objects which, like files, provide predefined cleanup actions will indicate this in their documentation. There are situations where it is necessary to report several exceptions that have occurred. This is often the case in concurrency frameworks, when several tasks may have failed in parallel. But there are also other cases where it is desirable to continue execution and collect multiple errors rather than raise the first exception. The built-in exception group wraps a list of exception instances so they can be raised together. It is an exception itself, so it can be caught like any other exception. Let's see an example of this. In here, I create a new file. Say example 11.py. Let's close this. In here, we're going to define a function f. We're going to say exc equal os error 1, system error 2, and then say raise exception group there was, rather there were problems. So passing the exceptions list. After typing my function, I can now run it here. If I do this, Python 3, and then example 11, I get the error, and we see that it shows us all the exceptions in the list. Exception 1, error 1, OS error, error 1, system error, error 2. Something that I need to point out about the exception group is if you're using an older version of Python, say Python 3.1, you will get a warning when you try to use this exception group class. If you open up the built-in function definition for the exception group, you will see that it says that this class was added in version 3.11. So you have to make sure that your Python version is at least 3.11 to be able to use this exception group class. And the way to do that is you can just do Python 3 -- version, and you can see my version here is 3.13.7. I had to upgrade my version to be able to do this example. I used this link here to install Python 3.13. I'm going to add this link in the description. This is for Ubuntu operating system. I don't have any for Windows, but if you can always check it online and install the current version for you. So let's continue with what we're looking at. By using except asterisk instead of except, we can selectively handle only the exceptions in the group that match a certain type. In the following example, which shows a nested exception group, each exception asterisk clause extracts from the group exceptions of a certain type while letting all other exceptions propagate to other clauses and eventually to be erased. So let's see this example. We define a function here. We'll say raise exception group, and then in here give our message group 1. Then we'll define a list here, OS error 1, comma, system error 2, comma, we'll have another exception group, and then we give him a message group 2. Then we define our list, OS error 3, recursion error 4. Save that. And now we try to run this function, try to execute this function. We'll say except asterisk OS error as E, print there were OS errors, and then except asterisk system error as E, print there were system errors. Save this and let's run this example again. As you can see, we have our errors. We have the first one, print there were OS errors. The second, there were system errors. And then we have the inner error here where we have recursion error for the sub exception error group. But notice that the OS errors and exception errors, both the one in the outer group and the inner group, as OS error and OS error, they've been handled by this handler, so they are no longer showing up in this re-raised error. The only error that shows up here is the recursion error that wasn't handled. Note that the exceptions nested in an exception group must be instances, not types. This is because in practice, the exceptions would typically be ones that have already been raised and caught by the program. So it follows this pattern for test in test run, and then exception as exe append e, and then if exe raise exception, so on and so forth. When an exception is created in order to be raised, it is usually initialized with information that describes the error that has occurred. There are cases where it is useful to add information after the exception was caught. For this purpose, exceptions have a method, addNote, that accepts a string and adds it to the exception notes list. The standard traceback rendering includes all notes in the order they were added after the exception. Let's see that example here. New file, example 12. We try raise type error, bad type, then exception as e.addNotes, add some information, e.addNotes, add some more information, and then raise there. If we run this example 12, we get the notes that we added to the exception after the exception was caught displayed to the screen after the exception has been displayed. For example, when collecting exceptions into an exception group, we may want to add context information for the individual errors. Let's see an example of that. Let's comment this. We'll say define a function here, raise OS error, operations failed. Try, say exe, define an empty list for I in range, 3, try f, accept exception as e.addNotes happens in iteration I plus 1, exe dot append e. Then here we say raise exception group. We have some problems. Yes. Now let's run this. We get our exceptions. We also get the notes. So happened in iteration 1, happened in iteration 2, happened in iteration 3, which gives us more information as to where these exceptions occur, especially when we are trying to debug an iteration. So that is it for errors and exceptions. If you enjoyed the content, don't forget to like, subscribe, and share. I'll see you in the next one. Bye.